So, welcome to the final webinar of the spring 2026 session of the monthly Mass AITC webinar series. As a reminder, we'll be taking a sort of 2-month hiatus before the launch of the 2026-2027 session. So we hope that you enjoy the 2-month break after today's talk. Um, my name is David Paquette, and I am the Associate Director of Research for the Massachusetts AI and Technology Center for Connected Care in Aging and Alzheimer's Disease. I'll be serving as your host for today's session. Today's session will serve as a high-level primer on best practices for digital phenotyping for with older adults. This is a rapidly developing field, one in which our speaker today is a leading expert. Dr. Raeanne Moore is a clinical neuropsychologist and professor of psychiatry at UCSD, where she directs the Mental Health Technology Center. Her research leverages digital health technologies to improve the assessment of cognition and real-world functional outcomes. Dr. Moore's work applies machine learning and AI to identify digital biomarkers that may predict cognitive decline. Furthermore, she is the co-founder of NeuroUX, a digital health platform that disseminates digital phenotyping tools for clinical trials, research, and clinical care. I've had the pleasure of getting to know Dr. Moore through the Mass ATC funded pilot project that she leads. And I'm looking forward today to learning more about sort of these digital phenotyping techniques, and hopefully today's session will be applicable to your research. And I'm sure Dr. Raeanne Moore will appreciate connecting with you all.
Well, thank you everyone for coming in the summer. I know everyone's busy this time of the year. I'm hoping this will be helpful. I tried to make it as practical as possible. And yeah, as David mentioned, I am an awardee of the Mass AITC pilot program, which has been just a fantastic opportunity to conduct some cool research. I'm not going to be speaking though about the project we did in that for that program today because we're still analyzing the data. We just finished collecting that. So, but I might have to come back another time and share our findings from that. Some disclosures. As David mentioned, I'm a co-founder of NeuroUX. I'm also a co-founder of a company called Keywise AI, and I will be talking about some data from both companies today. So the first part of this talk is I'm going to dive into kind of why is why do we want to do digital phenotyping? Why would it be important for our clinical research? How can mobile tools complement our clinic-based assessments? And what kind of data can they provide that we cannot capture from traditional assessments? Then jump into what it reveals and looking at different effects of context and state on everyday life. And then just some practical tips that hopefully will be helpful on designing protocols for digital health studies, and then also providing some examples of just some data we have across just a sampling of populations. And when I talk about digital phenotyping, really the definition, as I'm sure most of you are aware, is kind of this combination of collecting active and passive data from mobile and connected devices, and then putting these data streams together to create, do different advanced statistical analyses or create algorithms for some type of purpose, for a clinical outcome assessment or for a prediction or something like that. Most of what I'm going to be talking about today focuses on the active data piece only. So that would be things like our mobile surveys, ecological momentary assessment, as well as our mobile cognitive tests. Sometimes we also call that cognitive EMA or ecological momentary cognitive testing. I kind of go back and forth between some of the different terms, but when I'm talking about mobile cognitive testing today, I mean cognitive tests that are administered in a burst design, so repeated sampling, and self-administered on smartphone devices. I chose to focus most of the talk on the active data collection piece today because I think that of the data that exists today and is available, the active data really is in the place where it's most strongly positioned to really tell us a lot of information at face value in an easy to collect way for our participants, and is something that we're finding we get pretty good adherence on, where the passive data, participants don't really have to do anything to change their behavior a lot of the times, but we are still finding we have some challenges with adherence to that kind of data stream. So happy to answer more questions about that later if that is something of interest to you all, but for now, I'm going to move on. So when we think about the limitations of traditional assessments, particularly psychiatric or neuropsychological assessments, it really is just this kind of one-shot snapshot of cognition, or symptoms at a certain time point. It's very infrequent. Most often patients spend a few minutes with a medical provider talking about their symptoms, whether it's a psychiatric interview, or just a quick PHQ-9, or cognitive testing. You're lucky to get it once a year. I mean, for most people, they're not even able to have access to cognitive testing unless they're showing symptoms, and then even then the wait lists are like 6 months. Um, it's this artificial environment where ideally it's and I a great environment to assess cognition, without distractions, without interruptions. But given that we just have this single snapshot, maybe someone's having a really good day, they're not feeling stressed, they perform really well, their cognitive performance shows that they're doing really well, but then they're having all these functional impairments in their daily life and all of these problems, and it's not translating to their real world cognitive abilities. Vice versa, is absolutely true as well, where people may just have been running late to the visit, stressed for parking, didn't sleep well, or have their morning cup of coffee, and perform pretty poorly on this battery of tests. And particularly when we think about older adults, our battery of tests for cognitive assessments is really, really long. And there's the fatigue effect you get. People have attention problems. You can get distracted by internal states such as hunger, distraction, all of these things, which can really compromise the validity of our cognitive testing, and make it challenging to make solid recommendations on what's really going on with that person. So when we think about what kind of data we can collect via various digital phenotyping methods, I put here 3 streams of data. We can absolutely capture more than these 3, but these are kind of the main 3 that I focus on in my work, and then I think are kind of the most important for working with psychiatric populations. And that is cognition. And we can pretty much get every single domain of cognition via mobile technologies, through active and passive data collection. Also getting concurrently context and behavior. So you can use GPS to get people's life space data. You can use the accelerometer from the phone. You can capture keystroke data to capture patterns of typing behavior. You can get social activity passively. You can get a lot of this data as well just from brief surveys. So their location and the context is influencing how context influences cognition as well as other behaviors in daily life. Then you can also get all kinds of internal states. So here's just a few examples: mood, stress, sleep, etc. There are several now kind of groups in this space that allow for integrated capture of both active and passive digital data collection. NeuroUX is one where we get both active, provide the ability for people to collect both active and passive data via our platform. Cambridge Cognition, DataCube, MindLamp also provide integration of active and passive data, and that's just a few in the space currently. So when we think about what makes a good digital phenotyping study, there's kind of 3 main things to think about. And I'll go through each of these things in order. So thinking about the design of the study, where you want to do intensive sampling. It's important to sample people repeatedly over time so that you can get different contexts and capture different things such as diurnal patterns and capture people in different environments and across different contexts. It's better to do sampling in a short burst. So intensively sample behavior over, say, a week or 2 weeks, versus just like one sampling, once a month or once every 6 months, it's going to give you richer context of data in their everyday life. It's also important when we think about the design to tailor it to the particular population. And I'll speak a little bit more on that later. And then when you think about designing your study, you want to make sure you're planning ahead of time what analyses are going to be appropriate for what you hope to get out of all of this data. So there's lots of different analyses that that you can do, and you can look at all different kinds of variables that you're not able to look at with traditional assessments. One of the ones that's showing to be the most important is capturing that we capture variability in behavior, and variability in and of itself is an outcome that is showing to be very important for assessing cognition and other behaviors in daily life. And then operations is also something that's important to consider. And I'll talk a little bit about some tips we have for, making sure people are adherent to the protocols, um, balancing, the amount of data you want to get, and participant burden and feasibility with how much data you actually need. But overall, I think the key point here is really measuring people repeatedly and in context, and then analyzing change within an individual instead of just at the between person level. So, what digital phenotyping can reveal. So, the first, I try to divide these into multiple principles here. So, the first principle is context really matters. This is some data from a paper that's currently in revision. It was led by Dr. Ray Hernandez, who's at the University of Southern California, and using a large normative sample of participants in the United States who completed 10 days of EMA surveys coupled with mobile cognitive tasks, and found that the contextual factors that were affecting cognitive performance, distraction was the number one factor impacting performance. As would, make sense. When people reported they were distracted, they had consistently worse performance across their processing speed, working memory, recognition memory. If people were alone, they had better performance on processing speed, working memory, and recognition memory than when they were with other people. Similarly, if they were at home versus away from home, we saw better performance. And then we saw some impacts of engaging in passive leisure activity on processing speed, such as if people said they were at that time engaging in passive leisure, which was primarily watching television, they had worse processing speed. In this sample, we didn't really see effects from work or exercise, smoking or cannabis use. We didn't see a lot of instances of cannabis or smoking in this sample, which may be why, unsurprisingly, marked performance decrements when people were reported they've been drinking alcohol prior to taking the cognitive test, especially in processing speed and working memory. We also saw, when we looked at the relationships between psychological states and momentary cognitive performance, that if people reported at the time of taking the cognitive test, they were energized or excited, that actually had the largest and broadest benefits across multiple domains of cognition. This was surprising to me. I actually kind of thought we'd see the largest benefits from some of the negative mood states, but it really was if people reported they were energized or excited. We also saw consistent improvements when they reported they were currently relaxed. And then when people reported they were in a depressive mood state, or stressed, definitely had negative impacts on their real world cognitive performance. And when they reported they were having trouble concentrating, that's when we saw the strongest and most widespread impairments on all the cognitive domains. So really with this just the point I'm driving home here is that context matters. It's important to measure cognition in context to really see the impacts of what factors in our daily life, both internally and externally, are impacting our real world cognitive performance. This is data from a paper by Jason Hassenstaub's lab that was published in 2025, where they looked at contextual factors on people with mild dementia compared to cognitively normal adults. This was a large sample of older adults. The mean age here was 75. And they saw that amongst the cognitively normal participants, they didn't really see differences in terms of their mobile cognitive testing performance. They gave here a reaction time task. In terms of whether the controls were, at home and alone, at home, not alone, not at home alone, or not home alone, really no impact of the environment. But where they saw a significant impact of the environment was in their mild dementia group, especially in terms of when people were not alone and not at home. They had much worse reaction time. So higher means worse performance here. They're slower. And same when they were home, even and alone or not alone, they're still having, um, you know, you're not seeing it as much, this difference, but there are impacts here of context on cognition. When they removed all the sessions in which participants self-reported experiencing an interruption, these small effects of environmental distractions on cognition remained, and they were most apparent still in the mild dementia group. The next principle is that short-term cognitive variability is clinically meaningful. And it's important to think about variability as signal, not noise. This is some sample data from a couple participants from one of my studies of people with schizophrenia, where they did a 30-day protocol where every other day they were asked to complete some mobile cognitive tasks. And then they did EMA surveys 3 times a day for 30 days as well during this protocol. Um, and this is just an example from 2 participants. Where this participant one, they consistently were performing very well, and there was very little variability. But for this other participant, you can see each time they took this list learning task, we're seeing extreme differences in their performance. Um, and when we looked at variability in this sample and its relationships between functioning, we did see that participants such as this one, who had significant variability in their performance, had much worse daily functioning compared to people with very little variability. This is some data that's been published from the Einstein aging study. There's a couple publications down here. These are great papers if you're interested in learning more about variability in cognitive performance, particularly in mild cognitive impairment groups. These were older adults aged 70 to 90, including people with MCI. I'm just going to get all the animations up and going here. So on the top here, we have a high variability person in terms of their mobile cognitive testing performance. And high variability is associated with having a diagnosis of mild cognitive impairment, whereas low variability is not. Also seeing that high variability was associated with being positive for ApoE4, whereas low variability was not. And in some data that I'm going to present here in a moment, that being A beta positive is associated with high variability, where being amyloid negative is not. So this variability as a marker in and of itself has been shown across different studies and groups and contexts to be a marker of cognitive impairment. The next principle is that time matters. So this is data from several different studies. I'm going to walk you through each of them. The first 2 graphs here on the top is work done again by Dr. Ray Hernandez, where he looked at mobile cognitive testing data. So it was a mobile symbol search task where participants did it over a extended period of time. I forget the actual duration of this study. And they did it 4 times a day, and they looked at how time of day impacts performance on this mobile cognitive task. And they found that people were consistently slower in the morning, fastest midday, and then slower again in the evening. They also looked at mean response time to EMA items during the same sampling period. So just how quickly you're replying to these survey items. And they found a similar pattern, not quite as pronounced, but in terms of response times to the EMA items, that people are slower in the morning, fastest midday, slower in the evening. We've been able to replicate this diurnal pattern using keystroke data. So this is some data that was published by Claudia Vessel in 2020 using data from the BiAffect study of keystroke data, and in a sample of people across the lifespan, found that people typing, this is their mean inner key delay, so a lower is faster typing speed. Um, People are a little bit slower in the morning, fastest in the afternoon, and then slower in the evening. When we group people by different age bins, we see that older adults in particular have kind of a pronounced slowing in the evening. So thinking about even this diurnal pattern as a marker in and of itself for cognitive vulnerability. And then in an ongoing study I have in collaboration with Dr. Maria Marquine, who's at Duke, and Dr. Alex Demos, who's at UIC, we've had middle-aged and older Hispanics who are at varying degrees of risk for Alzheimer's disease and related dementias complete our keyboard for 60 days, I'm sorry, 30 days um, on their personal phone. And we looked at their typing speed and how it relates to their lab-based scores of cognitive testing, in particular processing speed, and found that for participants who did not have impairment on processing speed, we didn't really see this diurnal pattern in typing speed. But for people who did demonstrate impairment, this same pattern, such that people are, a little bit slower in the morning, fastest midday, and then this pronounced slowing on these cognitive impaired folks in the evening. So it's important to think about the time of day of testing, especially when you're looking at cognitively vulnerable and older adult populations. Next is I'm going to talk about just some design features that can help you have a successful digital phenotyping study. So I'm going to go through a sampling schedule, assessment burden, domains and measures, capturing context, as well as population fit. So this is a sample schedule. This was from one of my studies where participants did 14 days. They did, in this study, they did mobile cognitive testing, EMA surveys. They used the keyboard, and I believe we captured GPS data as well over these 14 days. This sample schedule is just showing the mobile cognitive testing protocol where we had 8 different mobile cognitive tests from NeuroUX that we administered over the 14 days. I wanted to make sure that we had good representation from each of the tests. So about 2, 3, I don't remember, 4, 5, 6, 7, 8 or 9 times they took each of the tests. And you really want to weigh the burden with the data you're capturing. So we made sure to only give them 2 or 3 tests at a time. And one advantage of these tests is that they're ultra brief and designed for this repeated administration. So each test is 60 to 90 seconds. So when you give them 2 to 3 tests at a time, you're looking at like 5 minutes. You pair that with a survey of about 1 minute, maybe 6 minutes, 3 times a day. And we found that that amount of data collection really isn't burdensome to people. Um, and we wanted to make sure that we stratified the tests so that they were getting them equal times each test over morning, midday, and evening. So the colors just represent the different times of the day. And that way we're able to look at diurnal effects on behavior. Also thinking about test selection, um, it's important to think about things that people are going to want and like to do. So with the tests we've designed, we've worked really hard to make them gamified and fun, try to keep people really engaged. We have built-in gamification features such as, they can win things like badges and streaks, things like that. We get a lot of positive feedback from the participants that they really enjoy taking a lot of participants call them games. We've even had a lot of older adults say they get sad when the protocol is over and they don't have their kind of little brain games anymore that they're doing every day. Um, but I think we were able to accomplish that level of engagement we did a lot of co-design with older adults, um, and making sure to integrate a lot of feedback, making sure all the features of the tests also are accommodating to older adults. So making sure the font is big enough, they have plenty of time to go through the instructions, to do a little demo of the tests, make sure we're accounting for color blindness, making sure it's easy to do, even if people have some kind of tremor or other physical disability, that would make it more challenging to respond to tasks. So those things are really important. With a lot of passive data, which again sounds so passive and easy, but there are a lot of things people have to do every day, which can feel kind of burdensome. And if they're not getting a little bit of something out of it, it can make adherence more challenging. Really want to make sure you're keeping your surveys and sessions short. It can be super tempting to want to give everything in the kitchen sink because you're like, I can capture all of this data. I can, let's do it. But we don't always, just because we can, doesn't mean we should. So it's important to have make sure you always have your a priori hypotheses and then just choose the data that you really need for your study. When designing your EMA surveys, and I do always recommend pairing the cognitive tests with short surveys to capture that context. Um, Keeping those very brief using strategies such as advanced branching. So if people respond one way, then it branches to subsequent questions and it can keep the survey as brief as possible. Also, just you can have different questions, different times of the day. Um, I like to, when a study is ongoing, um, unless it's a clinical trial, it's locked and we're not allowed to change the protocol. But if we can, look after like we have had the first, I always like to look after the first, 5 participants, then 10, then even after the first 20 participants, modify your protocol as you go along too. So if there's some questions that you're asking on your survey, and participants are always just endorsing no, never, or you're not getting any data from those items, just remove them. That also helps keep the sessions as brief as possible. Or if you're finding, we had this issue recently in this study where we were capturing mobile data in bursts, 10 different bursts over a 2-year period. And we found that after about a year, we were doing 10 days of data collection once a day. Participants' adherence was just dropping. So we kind of modified the protocol. We dropped it to 5 days. We changed our incentive structure a little bit to pay them a little bit more, and that helped keep adherence at the level we were hoping to get. Um, I do have here, more on this later, but incentivizing participants is so important, especially for capturing this real world data. People typically pay $1 or $2 per session. That might be going up more. We've had to start kind of increasing that a little bit with inflation lately. But just, those micro incentives can be very, very helpful for adherence. Um, and I always recommend designing your protocol to capture more data than you need. So, for example, if I want to capture 7 sessions of mobile cognitive testing data, because I found for most of our tests, we need about 7 data points before the performance starts to stabilize and we have less variability. Then I'm gonna have the protocol be designed where 10 will be administered. And then, I'm assuming we'll get 70% adherence and I'm still gonna get the data I need. If you're interested in learning more about change in data quality over time, this is a fantastic paper that was just published this year led by Arthur Stone, who is just an OG in EMA research, and he and Stefan and Ray, they're really leading the way on methods for analyzing EMA data. So highly recommend that paper. And then when you think about wanting to capture context, so I already mentioned, I do recommend always capturing EMA self-report some contextual data, even if you want a purely passive study. I do think it's helpful to also capture some self-report data to really kind of, benchmark that passive data as well. There's all different kinds of contextual data you can capture. I already touched on this a little bit, but passive data, you can get so much data from the phone. You need to choose what data streams you do want to collect. You could capture all of them. If you try to do all of these in one protocol, you're going to kill that participant's battery on their phone early in the day. So you really need to select, which ones you want to get and what's going to preserve their battery and what's going to also be something that they're comfortable contributing. So, maybe if you're doing a study, I'm not good at making up examples on the spot, but looking at, I don't know, dementia risk in participants, and you're like, oh, it would be super cool to capture like all of these things, everything about them and everything they do and everything they see. Um, but some of that data can be pretty invasive. For example, like if you want to capture, what people are saying when they're talking on the phone or reading their text messages, right? Kind of a benchmark I always like to set for myself is would I consent to this project if I was asked to contribute all of this data from my devices and use that as my own personal kind of gut check for what I want to ask my participants to do. When we think about different populations, here's just an example of a few different populations that I've worked with. But when we're designing our protocols, we want to make sure we're adjusting scores for age because we definitely see age effects for most of our cognitive tasks, as well as probably for a lot of the other data, right? You can even think about life space and mobility and some of this data we can get passively. I recommend fewer prompts per day, but being consistent with the timing sometimes for this population can be helpful. Also recommend, if you can provide a study phone, make that an option. Most people now have smartphones. However, some people either share them amongst their family, or don't want to use them for research purposes. And so just having that option available can really help increase trust for the study and engagement, especially if you're capturing some of the more sensitive, passive data such as GPS data. Sometimes people just don't want to use their personal phone for that. Um, Study phones can be really inexpensive to get, and you can mail them to participants if you're doing a fully remote study, and it really isn't cost prohibitive to do that. We also send wearables a lot to participants because I like to get the same wearable for all participants in studies. And again, you can reuse them, and it is pretty cost effective. When we think about our psychiatric populations, again, a lot of the similar tips, providing phones, um, especially in these populations, particularly important to pair cognition with mood, and other symptoms. Um, Also really focusing on adherence is something that, and keeping an eye on it kind of regularly is important in this population. With our older adults with dementia risk, we typically have excellent adherence. Like I'm talking 90% for the most part. They're like fantastic research participants. Um, for our psychiatric populations, it's a little more challenging. And so having your research team and just the technology you're using provide, reminders if they're missing sessions. I typically have my team monitor. We have a dashboard and they can monitor if people have been doing it. And if they miss, say, 3 in a row, I have my team reach out via the patient's preferred contact method. So if that's text or phone or email or all of the above. To kind of troubleshoot. Maybe they're having some issues with the phone. Maybe they forgot to charge it. Maybe they just forgot to do the study or haven't been paying attention to it. So to try to get them back engaged in the study. When we think about some of our like more medical or veteran type populations, um, it can be super interesting. And based on our study question, important to try to align the burst with clinical events. to capture symptoms and disability alongside cognition. And, if you are kind of doing something integrated with their healthcare team or healthcare system to coordinate with their care team on the data flow. So I touched a little bit already on maximizing adherence. This is just an example of the dashboard that we use that just is a nice, easy way for the staff to go in and see like, okay, green, they completed it, red, they didn't, yellow, they did a partial session. And then we just set protocols in place for if they miss so many in a row. They get contacted in terms of providing, compensation to participants. That can all be tracked here as well. In addition to doing the per session um, compensation or like per day for passive data collection. Sometimes we'll do like $5 per each day you contribute your passive data or whatever. I typically like to include some type of bonus, such as like if you complete 80% or more of your sessions, you're going to get an extra $50 or whatever it may be. Um, It's also important to, especially for some of our psychiatric populations, we've found to have in-lab tutorials on completing the phone tools. So, and assessments. So having someone, if you can be in person with the participant or even over phone or on the Zoom, kind of going through a practice session, walking them through just how to do it. For NeuroUX, a lot of our sessions can be pushed out via web link. So just showing them where to go to the text and click on the link and then what that looks like. I also always recommend sending home a physical, so printed manual, participant manual that has all kinds of information, such as, contacting the study team, how to complete the sessions, how to charge the phone, how to make sure to keep the passive data collecting if you're doing that by updating that app once a day or whatever it may be. But all of those things can be really helpful for adherence. From the participant side of things, check-in calls are very helpful. We usually do a first day check-in if they miss a few in a row, and then also once every other week, just if you're doing a longer protocol to check in. I already touched on the financial compensation, and it's great to build in into the platforms if they've earned money, and then you could see that money ticking up over the session. So, if this was, say, they just done 10, then it's be like, you've now earned $10, and they can see that progress they're making. Same with kind of these non-monetary kind of intrinsic reward gamification features. This is one I love that we have where it starts out as an empty tree branch and then participants have a flower bloom each time they complete a session. We get really great feedback on that. They can also be earning badges, levels up, things like that. And then when thinking about cognitive tests in particular, it's important that we have standardized data. And so this is a paper that was published by Dr. Emily Paolio, who's an assistant professor at the UCSF, also a former mentee of mine. And this was in a normative sample of adults in the US, aged 20 to 79. And we wanted to get normative data on our test. And so we published all of the normative data features, including average and within person variability and performance, alternate form test retest reliability, stabilization, metrics, practice effects, the context associations with demographics and text taking contexts. Also interested, or also made sure to create demographically adjusted and unadjusted T-scores that are available for people. And then we um, also wanted to consider, one thing to consider also is phone type. So we have found, especially for like reaction time tasks and some of these processing speed tasks, that we see phone type differences, particularly if someone has an older Android phone, their response latency is much slower. And so you're going to want to control for that. In this paper, we make recommendations on controlling for the different phone types. There's also an excellent paper from Jason Hastenstab and his lab where they actually built a robot in their lab and examined response latencies on all the different kind of devices that were available at the time and made recommendations as well for controlling for device type. One nice thing we see with iOS devices is we don't really see differences across the different iOS versions. Apple's been pretty consistent with their response latency, and same with iOS versus the newer, more expensive Androids, such as your Samsung Galaxies and things. We don't really see differences. So it's really when people have some of these older phones. But you make sure, you know, you want to capture all of that data. Their phone type as well is going to be important. Um, in our normative sample, we did see that older age was associated with worse performance on most of the tests, as well as greater within-person variability in reaction time. And we saw that being at home was associated with worse processing speed, and being alone was associated with, I'm sorry, a better processing speed. Being home, better processing speed; being alone, better recognition and working memory. So thinking about those contextual factors, even in a normative sample, is important. Here are just some common mistakes that I've seen people make using digital phenotyping methods. Um, I just looked at my time, and I'm gonna move along here pretty quickly, but take a screenshot of this, or I'm happy to share my slides later. But these are just some common kind of pitfalls and things you can do to avoid the pitfalls. I've already touched on most of these already, so I'm gonna move along. So I wanted to share some data with you from that we have from some different protocols. This is some data led by Dr. Andrea Weinstein at Pitt, who's been looking at the sensitivity of mobile cognitive testing to biomarker risk for Alzheimer's disease. This is a sample of 85 older adults. Their mean age is 73. And they have people into their 90s in this study. And you can see pretty well matched male-female group, where we had about 21% of the sample was A beta positive, 42% of the sample was tau positive. And these are people with preclinical risk for Alzheimer's. Adherence to the protocol was fantastic. So they were administered 40 sessions of EMA and mobile cognitive tasks. And on average, adherence we saw was 37%, or 37 out of 40. One thing that I wanted to point out as well that we've consistently found across different studies is that adherence early on to a protocol is a significant predictor of adherence throughout the whole protocol. So if someone's a really poor responder early on in a study, that person you can reliably predict is going to be a poor responder throughout. So you can make decisions very early on. If you have a poor responder, either you want to keep them in the study, maybe you don't want to keep them and replace them, or you're just going to have to know that they're probably going to be a poor responder and they might need a lot of additional reinforcement throughout the protocol. What is really interesting that Andrew has been finding with these data is that variability on several of our mobile cognitive tasks. So this is a reaction time to a executive functioning task called the color trick, um, is able to differentiate the amyloid positive from the amyloid negative participants, such that A beta positivity was associated with higher mean reaction time. Here, we also see it's associated with higher in-person reaction time variability. So both at the mean person level and the within person level, we're seeing this variability is able to differentiate these groups, whereas their just performance on the task, their mean performance was not. Similar findings with matching pair, which is a processing speed task. We're seeing that A beta positivity associated with lower mean accuracy. And also you see much larger effect here that amyloid beta positivity associated with higher within-person reaction time variability. And on a test of working memory, we're seeing that amyloid beta positivity associated with lower mean memory matrix scores. Interestingly, in the sample, there was no significant association between amyloid beta and memory. Like this is a recognition memory test. And, you know, as I mentioned, this is a preclinical sample, and typically memory isn't impaired um, as early as some, or impacted as early as some of these other cognitive domains. So it's these tests are showing they may be more sensitive than traditional assessments to preclinical stages of the diseases, especially when you're looking at that variability in performance. In this study, this is a study that is currently in press that's led by Dr. Yansu Song at UCLA. And in this study, it's a study of persons living with dementia and their care partner. It's a dyadic sleep intervention study. And what we wanted to do, we just wanted to see if persons living with dementia were able to complete our mobile cognitive tasks and provide reliable and valid data. So in our sample, and this was a pretty, this is a sample age 71 to 97, we had the mobile cognitive testing sessions sent to the caregiver's phone, which the caregiver is usually a spouse. And then the caregiver passed the phone to the person living with dementia and had them complete the tasks. And we did see that the persons living with dementia were able to provide reliable and valid data. Of course, much performance was much worse compared to cognitively unimpaired older adults. And much slower, but we did see normal distributions, and just showing that they can provide reliable and valid data. Then we looked at how the mobile cognitive testing performance of the dementia patients was related to sleep quality of the caregivers. And we found that performance on the mobile cognitive test they did here, better performance on the part of the person living with dementia was related to better sleep quality in the caregiver. But we did not find that relationship when we looked at the relationship between the MMSE and the sleep quality in the caregivers. So again, showing that these mobile tests may be more sensitive to real world outcomes than our traditional metrics. This is some data from Dr. Kate Papp, who's part of the Mass AITC. I wanted to highlight because this is super cool data that she's been doing, showing that these multi-day learning curves can be digital biomarkers. So this is from a study that she published in 2024 in the Annals of Neurology. It's a great paper if you go check it out. And basically they had participants complete the branch battery, which is her mobile cognitive testing platform, over a 7-day period. And found that in the amyloid positive group, there was this diminished learning curve across the 7 days compared to the amyloid negative group. There was no differences on day one, which is important, on their mobile cognitive testing performance, and there were no differences between the participants on in-lab testing. So it really is this repeated sampling across time and looking at how performance is changing over time that is able to show something meaningful between this preclinical group. In another application, this is some pretty cool data that was recently collected by Dr. Ashley Hennigan and Dr. Alex Haynes. They're both at the University of Texas, Austin. And they were interested in looking at cognitive changes associated with melanoma diagnosis and surgical intervention. And so what they did for a protocol is someone came to Dr. Haynes' clinic, was diagnosed with melanoma, told they need surgery pretty soon, were then approached by a research assistant in the waiting room often to say like, hey, you were just diagnosed with melanoma. Would you be interested in doing this study? Surprisingly, they got a lot of people to agree to this. And so the participants did a 7-day lead-in period of EMA surveys and mobile cognitive testing immediately following that pre-op appointment. And then they did data collection once a week for 2 to 7 weeks with surgery in the middle there. And then they did a post-op intensive burst again at week 8. And what they found is they found pretty good participant feedback data, such that when participants were asked how challenging was it for you to complete these daily tests, the median score was 20 on a scale of 0, not at all, to 100. They found that amongst participants who responded to how do you feel about incorporating the smartphone tests as part of your ongoing care to monitor your cognitive intervention, 93 participants indicated they would be receptive of that. And if you look up here, we have the adherence rates. So the pre-op adherence rates were overall pretty good, as well as the weekly, and then post-op, fizzled a little bit, but you have your super completers, right? Who are always your super completers. And then you have your people who, as I mentioned, crappy adherence at the beginning, and that continues throughout. So these were I confirmed with Ashley, this is the same person there. So what did they find? So they looked at individual differences in how cognition effects of stress and anxiety. So on the y-axis here, we have the mobile memory list test. And then on the x-axis, we have within person change in anxiety. And then the different colored lines represent, they also did a lab-based CNS vital signs. And this is their composite score on that lab-based cognitive assessment. Green is mean performance, red is one standard deviation below the mean, and blue is a standard deviation above the mean. This is the same graph, except for instead of anxiety, we have stress on the x-axis. So just to orient you to that. What we found is that for people with above average cognition, when their anxiety or stress goes up a little, their memory got better. It's kind of like their brain was saying, okay, this is challenging, like let's focus. But for people with kind of weaker baseline brain skills, who had some impairment at baseline, when their anxiety or stress goes up, their memory got worse. It's kind of like their brain got overwhelmed. So just thinking about clinical implications for this type of work, can think of lots of valuable clinical implications for really measuring how people are going to be able to hear medical information that's being provided to them, to understand their treatment and to just deal with medical procedures and decision making. Um, Screening can identify vulnerable patients, especially if we have people with anxiety and cognitive vulnerability. They may need some added support. And then quickly, I am going to wrap up here. I want to make sure there's a couple minutes for questions. Um, where is the field going? A lot of people are doing work in passive and active data fusion. Um, and again, I just want to bring home the point that make sure you only capture the data that you need, and you don't have to capture everything in the kitchen sink every time. Do adaptive protocols, do personalized protocols based on your participants and based on your study questions. And the field is going more and more to personalized protocols and care. And then this is something I'm really excited about and happy to see more and more of is the biomarker integration. So pairing digital with the biomarker data, I think is really going to help improve our clinical trial endpoints. And then thinking about clinical handoff too. So now we're seeing more and more clinics, at least talking about slowly starting to integrate using these digital tools to improve clinical care. I already touched on a lot of this, so I'm just gonna say thank you to everyone. I'm sorry if I left anyone off of this list. It takes a village, and happy to take questions. Here is my email. If anyone is interested in reaching out, always happy to collaborate. If I don't respond to you, please email me again. Thanks.
Yeah, so I guess we have probably time for one or two questions. So if people want to either put in chat or unmute and ask your question, we can go from there. You mentioned sort of the work with EMAs and sort of this methodology with sort of in dyadic situations. So I'm wondering if there's any practical lessons learned or things that are unique to that population where you've sort of noticed, best practices or things that you need to do to maintain adherence, say, across both the caregiver and the person living with dementia.
Yeah, so I mean, the burden of the data collection really falls a lot on the caregiver in this dyadic study. So we wanted to make sure we weren't asking the caregiver to do too much. So when we designed the protocol, we have a 7-day lead-in period for the caregiver where they're just doing EMA and wearing an actigraph watch. Because it's a sleep-based intervention study. So that was the key data kind of we wanted to capture. And then we also asked them to, and during the EMA survey, they're also talking about the participants answering questions about the participants' behaviors, or the person living with dementia, and then just asking the person living with dementia to do the daily EMA test or the mobile test for, I think we had them do it for a week. Um, I would have loved to get more data from the caregivers, but again, it's kind of balancing that burden from the data we really need.
I guess one thing that sort of came up is that you mentioned sort of like the context matters piece. And so I assume, like obviously we've seen differences where in people that may be pre-symptomatic or mild cognitive impairment. I know like Penn State and Marty Selinsky have this Omni ADRD where they're trying to look at, what are the right measures and things to assess. So is there what is the research in that space in terms of introducing define distractions or other things to some of these assessments to try to maybe tease out, sort of increase these sensitivities by providing a stress in the assessment, so to speak, versus sort of just asking a straight, question on a cognitive exam. Like, is there, I guess, what are people doing? Is that something that you guys are actively looking at to incorporate?
Yeah, so I mean, we typically just ask people in the moment how distracted they are, if they're having trouble concentrating, if they're feeling interrupted. And the in the moment data we find is pretty good. I've started though, I'm in this working group where we're actually trying to like standardize kind of how we ask these questions for clinical trials and things. And one thing we talked about is really honing in on the types of distractions because the FDA is going to want that. So is it, an external distraction, a dog barking, or, a plane flying overhead? Is it an internal distraction, such as like hunger, or you're just thinking about like what you're gonna like watch on TV tonight? To quantify that a little bit more. Yeah, but for us, I mean, I feel like the self-report's pretty good. And we've done a little bit of, having studies where we'll turn the microphone on in the background to capture social
Hmm.
context. So it just captures like other noise in the background, and that can give you a kind of more objective marker of distractions that way. But I don't know, I'm just a big believer in like usually people can provide pretty solid self-report data in the moment if it's not based on like retrospective recall. Um, and people, you know your own experience more than the environment will know
Yeah.
your experience. So I don't know. That's my bias perhaps, but
Okay. Well, we're pretty much at time, so unless there's a quick question that comes up, oh, someone saying thanks for this interesting presentation. We'll leave it. But so thank you, Dr. Moore, for providing this great overview on sort of best practices and sort of how you guys are using and sort of developing both, in your personal research and through sort of the platform that you've developed and launched through Neuro UX. And so hopefully people will reach out to find more about that and how to use it and, maybe get some feedback on studies that they're developing. And with that, I hope everyone have a enjoy the rest of your Tuesday. I know on the West Coast, people have more time. It's the end of the day for us out here on the East Coast. But so thank you again, everyone. And we'll see you in September for our next session. Bye, everyone.